All right, good afternoon, everybody. Welcome back to another live stream. And again, apologies about yesterday. It's rather unfortunate that, so 2 p.m. Central Time on Friday is when I prefer to do these streams, just because that is honestly when works out the best for me and my family and our schedule. And I have just had rotten luck lately with 2 p.m.s on Fridays. Whether yesterday was Wi-Fi, times before it's been the service that I use because I simulcast to LinkedIn and YouTube, and I use a service called Restream. And it's a great service, but I don't pay for it because there's like a free tier and a paid tier. And like, I kind of have a hunch that people are using it a lot at 2 p.m. And so I've had issues with that. So yeah, I'm thinking about what to do about that long term, but, I appreciate, everybody's understanding about that. So, but here we are today. So, unfortunately, we didn't do yesterday's live stream, but here we are today, and we're gonna get into it. And again, if you ever miss one of these live streams, just be aware that the replay is always available on YouTube, and I think it is on LinkedIn too. But LinkedIn's a little bit more challenging to like scrub through to find like a certain place or anything. So I would encourage YouTube actually. So yeah, let's go ahead and jump into today's live stream. So today's live stream is, now I always have one of these, but this is extra appropriate today. I have my Polar Pop. I don't know if you can see that Polar Pop. And because today we are talking about polars. Now, if you are not familiar with what polars is a newer Python library that is specifically designed to be a data frame alternative. So the big alternative, the big comparison that people like to do is doing the data science industry favorite pandas versus polars. And the reason that polars is starting to gain a lot of traction is because polars is being written on top of Rust. And if you're not familiar with what Rust is another programming language that is gaining itself a lot of traction as a great alternative to C++. Now, to be completely transparent, I am not a C++ coder, and nor am I really that familiar with Rust. And for the good news is for our purposes here, that really does not matter. And in fact, you'll actually see we don't even have to install Rust necessarily, because that was one question I had whenever I jumped into here. Yes, the stream is recorded. So I see your comment there, Ravi. So the stream is recorded both on LinkedIn and YouTube. It's just easier to kind of scrub through if you miss something and you want to go back and do that on YouTube. Yeah. So yeah, and by the way, there's about a 20-second delay between my my liveness versus like what you all are seeing. So just be aware if I don't see a comment right away, that's probably why, is that 20-second delay. But yeah, so where was I at? Oh, okay. So anyway, so polars, being an alternative to pandas, I thought I would check it out and see what's all the hype about. Now, to be transparent, and I think the polars people would be transparent about this as well, is polars is still in a very early state, I would say. I've seen some really cool things with polars so far, and I have seen some things, and we'll talk about these more in detail in a little bit, of it's just not ready yet. And just jumping ahead to the end, kind of, my recommendation is to not use polars for a production setting today. I think there's just enough that polars is not ready for prime time that I would not recommend it if you were wanting to use it in like a huge company. I do work for State Farm. I'm not going to use it for State Farm's context, at least not in its current state. And then there's also the question of people are comparing it to pandas in the pandas performance, because you always wonder with any software product, will it catch on and will it basically become the new norm? And so there are really awesome things about polars, and there's really nothing stopping pandas from adopting these things. Well, I guess when there is, the whole legacy technical debt, I don't know if you'd call it technical debt. So if you really wanted to rewrite polars or pandas from scratch to emulate polars, I think that would take a huge undertaking. But yeah, I lost my train of thought there. But basically, I would not recommend polars at this time, and you'll see why. So today, what we're going to do is we are going to do a direct compare and contrast of polars versus pandas. So, and this is really more so designed for people who are already familiar with Pandas. So to be completely honest, I try to do some of these streams that are more for beginner levels. This is going to be a more intermediate to advanced kind of live stream today, but I will try to make things as simple as possible for you to understand. And actually, you know what? You may learn something new about Pandas that you didn't realize today, or you didn't know before too. So, all right, enough of that introduction. Let's go ahead and jump into my screen. Oh, and I guess I should say we will be doing this all in the context of working with the Titanic data set. So just for simplicity's purposes. So let me make this bigger for y'all so you can see this. So the first thing we want to do, of course, is we want to install polars. We want to install polars, and the way you do that is very simple. So like I said, even though this is being written in Rust, you actually do not need to pre-install anything associated to Rust. All you need to do is do a simple pip install, or if you use Anaconda, I think it's like a conda install. So you could do pip3 or pip install polars, and this is obviously just gonna say I'm already good to go for you. It might show the downloading thing. So that's it. That's really it. Now the one other thing is that we do need to download another package also called PyArrow. Now to be transparent, I'm not super familiar with what PyArrow does, but I did notice, and you'll see along the way that because Polars does have the capability to convert Pandas data frames from or to and from. Polars has the capability to convert data frames to and from Pandas, and in order to do that, you also have to have PyArrow. Now, fortunately, installing PyArrow is just as simple as installing Polars, and that is so pip install PyArrow. Now, obviously, I'm already good to go here because I've already done my work beforehand. So that's really all we need to do for setup. Now, I guess the one other thing that I do want to call out here, is as we proceed forward today, because I do want to measure the performance of how Polars compares to Pandas. I wanted a clean way to do that, because what you can do, I don't know if y'all are aware, so this is a Jupyter Notebook interface. If you want to show like the performance of how long it took a cell to run, you can run what is called a magic command. And so that begins with the two percentage signs like that. Let me zoom in here to make this a little bit bigger. And then you could do time, and then let's just do I don't know, print hello world. Okay. And so what you can see here is that it printed out hello world, and then it runs shows the CPU time. So it ran in 74 microseconds and a total of X number of microseconds. But I don't want to have to type this out every single time. So what I discovered is there's actually an extension that you can use for a Jupyter Notebook, and you can actually see it here. I already have the extension running. Now it's kind of interesting that I'm seeing two different times here. I'm seeing the microseconds here and the wall time here, and then it looks like, well, I guess that is about right, because what is it? Is it 110 microseconds to a millisecond? Because this mu symbol is microseconds versus this m, which is milliseconds. So I think that's about right. So if the wall time is 18.5 microseconds, then is that 19 milliseconds? That might be right. But anyway, so if you would prefer to have like this, where it's clean and tucked out of the way, and something that we don't have to run every single time, you do. Here's how you do it. So you have to install, so do a pip install of Jupyter Notebook extensions, Jupyter Note. I think I probably did a pip3 install. Pip3 install Jupyter Notebook extensions like so. So those are already all good to go. And then you can do run a couple of other commands that will get this going for you. Here, I know you can't see this. Oh, sorry about that. All right, there we go. All right, so then you would run, and by the way, I'm actually writing a blog post that's basically going to be this stream in blog form. So if I'm doing anything today and you missed some of the commands and stuff, don't worry, it will all be in the blog post as well. And I hope to have that published tomorrow, maybe. It's been a busy weekend, so it might be a couple days. But anyway, so you would run the Jupyter command, Jupyter contrib NB extension install users. So this is going to install the extension appropriately. And then to activate it, you run Jupyter NB extension enable execute time. And then so that's already good to go. So this is already all turned on. And then and then the next time you fire up your Jupyter interface, if you go to cell and then you will now have, so this is not typically in the native Jupyter Notebook thing here. This execution time is here. So then you can toggle on the visibility here. And so I just toggle it off right now. So now you notice that thing went away there. And so now I'm going to toggle this back on. And so now we can see this piece here going forward, and we don't have to type this magic command every time. So anyway, so yeah, let's go ahead and the reason, again, I want to show this is because one of the big perks of polars is that I'm all washed out. Sorry about that. Turning down my light some. One of the big advantages of polars that it's touting is that it is blazing fast. And in my experience, I actually think this is true. It actually appears to be like almost like half this, or like it often takes polars half the time to do something that Pandas takes, so which is amazing. That is a drastic increase. All right, so let's go ahead and get things going here. So we're going to go ahead and import both Pandas and polars. So we're going to do import Pandas as PD. So we typically alias Pandas as PD, and then we typically alias polars as PL. So we're going to import those. All right, execution queued. All right, so I don't know why that took so long. But it did take a little bit there for both. All right, but they are both installed. Now, I do want to note the Titanic file path. So Titanic file path. So I do have that in my local directory already. So it's up1 data Titanic and then train.csv. So we're going to load that up, or I'm sorry, set the file path. And now we are going to make things as understandable as possible going forward, I'm going to end all my variables that I'm using in the respective technology that I'm using. So that probably doesn't make sense, but so to make it easy, so I'm going to load up the data frame for Titanic as df pandas and pandas. So df pandas, and this is what I'm talking about. So everything that I'm doing in pandas is going to end in this underscore pandas, and everything that I'm going to do in polars is going to end in underscore polars, just to make everything really understandable. And I'm doing this live, but to be transparent, I've already done a lot of this work in a different notebook. I just haven't pushed it up to GitHub yet. And I don't mind showing it to you already. Just to be transparent, we are going to be doing stuff live, but as I've said in previous live streams, if I don't have something prepared, then I am kind of a mess. So so this is the stuff you'll all see once I clean it all up and stuff. But as we scroll down to the bottom here, you can see some errors and stuff. And that's because I'm running into some issues with some things. So because polars again is not perfect. Okay, so let's come back to here. df pandas, so PD, the way that we read in the CSV, so that's pandas read CSV, the file path, Titanic file path. Okay, so finished in 16 milliseconds there. Now here, so this is where things get interesting with polars, is sometimes the syntax for polars is similar, sometimes it's the exact same, and sometimes it's very different than pandas. So for reading in a CSV, it is fortunately the exact same. So df polars equals pd.read CSV, and we're going to pass in the Titanic file path, and there we go. Now you'll notice already here. So look at the performance in simply reading the CSV in 16 milliseconds versus 11 milliseconds. Now, to be completely transparent, this is a trivial use case. So time does not matter a whole lot here, but when you start to think about big data and working with a lot of data, this is, what is that? I don't know. It's 40% faster. That is a huge gain. Like talking just, 5 to 10% faster. We are talking 40 to 50% faster than Pandas. So that alone, and this is going to be a recurring theme. Now, to be transparent, you'll also see along the way, I actually noticed there's been times where Pandas actually ran a little bit faster than polars, and which is curious. But most of the time, you'll see today, polars does execute much faster than Pandas. So we've read these in. Now, what I typically like to do, so I'm going to call this my getting started section. So I'm going to just for our purpose, I'm going to call this getting started, because data scientists like to do a couple different things anytime they work with any sort of data set, and that is so I just like to look at the data, and I like to look at the null values associated with the data and whatnot. So the very first thing I always do is I always just run the head command. And so if you don't know what the head command is, that's just going to show you the first 5 rows associated with your data set. So let's do this in pandas. So df pandas dot head. All right, and there we go. So what you see here is we have the columns associated to this feature set. Passenger ID survived, so survived is our predictor value for this data set here, and then so on and so forth. And so this is the standard Pandas interface. For you Pandas users out there, you are probably very familiar with what this looks like. Now let's do the same for polars. Now again, fortunately, this is one of those instances where polars is fortunately the exact same syntax, so you can do a polars.head. But when I execute this, you're gonna notice things look different, and I actually really like it. There's one aspect that I don't like, but you're gonna see with this. So, did I read? Oh, okay, I screwed this up. PL dot. All right, that's funny. So I just went on this tirade about how polars was so much faster, and then I didn't even use polars in the right context there. So let's restart and clear the kernel, just to see if it was faster or not. And I'm getting different execution times, but like let's do that one more time. So this one was faster again, but let's do it one more time. That's a little bit embarrassing, but I mean, I will say, so like there it was exactly the same, and maybe it's because we're working with such a small data set that it doesn't matter. But anyway, so here's the Pandas data frame once again, and then so let's scroll down. Now here's the polars data frame, and I actually really like this for a couple reasons. Number one here is right underneath the column, you get to see a truncated version of the data types right off the bat. So you can see that passenger ID is an integer, 64-bit integer. Same with these others. You can see the age here is a float 64 value. And this is also what I really like here is that it's actually very clear what like the name category is here from two different aspects. So that's the one thing that I never was wild about Pandas about is so this was and I'm gonna jump ahead here a little bit. I didn't mean to show this quite yet, but one of my other favorite things that I like to do is the info function. And so you can see here when I look at the name here that it's showing the data type as object, which is not very helpful. And so in order to understand that this is actually a string, you have to do it is possible to find out that, yeah, this is string, but it's just not as clear right away as opposed to polars. Polars puts it right front and center. This is a string, and you can even see with the string values, from a display perspective, it is wrapping it in quotes, and I love that. I think that's really nice, really clean. Big fan of this. And you can also see that it is outputting the shape. Now here, because we're only returning 5 rows, that's why it's only a 5. But in reality, there is 891 records in this training data set. So yeah, I do really like this. The one thing I'm not wild about is you'll notice that the index values are not present. So you can see that these bold in the Pandas data frame, the bold numbers here represent the index values of each row. These are not present here within the polars data set. Now that doesn't mean you can't call things by an index value, and we'll demonstrate that here in a little bit. I just kind of wish that they were there. It's not a huge deal, and I actually wouldn't be surprised if they eventually added this. But otherwise, I really, really like this, and I really wish actually Pandas would emulate this. So this is one of these things I've already said toward the top of the post. There are things I really like about polars, and there are things that don't work so well. This is one of the things I really, really like. But maybe that's just me. All right, so that is just viewing the first few rows. Now, I guess so. Coming back to here, this is another function that I really love to run, and the thing that I really like about this is that you can get a very quick sense of, okay, I got 891 records here. Here are the name of all my columns, my features, and here's everything that is non-null. So we see, right here, the age has quite a bit of nulls. We see embarked has 2 nulls here. So I really like this view. This is unfortunately where we start to deviate a little bit with polars. Polars does not have a correlative function like that. So, if I ran df polars, here, let me make this bigger for y'all. If I ran df polars.info, I get nothing back. And so additionally, another thing that a lot of people like to run with Pandas is a different kind of function called df Panda. So it's called the describe function, and this gives back correlation statistics and stuff, or not correlation statistics, but like like just describing the values and stuff. So like and it's showing just the numerical values here, but it'll show like, okay, here's the mean for the I guess I shouldn't use passenger ID because that's passenger ID is kind of a nonsensical number in this context. But like, let's use age. Age makes sense. So the mean age of these values is 29. I don't see a median here. I thought median wasn't here. But standard deviation is 14. The minimum value is 0.42, meaning that the youngest person on the Titanic was like right under 6 months old, something like that. And so this is a nice view. To be completely transparent, and this may just be because I don't do a whole lot of modeling myself. I don't really care for this function so much. But the interesting thing is that Polars also has a describe function, but it is different than this one here. And the reason I'm talking about this one, like describe and info in the context of Polars in the same breath, is because, well, let's just go ahead and show you df polars dot describe. All right, so now we are seeing some similar info to describe and some from Pandas describe and some similar info to Pandas info. So we are not getting the 25th or the 50th or the 75th percentile on things, but we are getting things like median. We do see things like the null count. So this is where the null counts are coming in. So this is all correct. And we can see the counts, we can see the mean. It's just like Polars decided, instead of saying, okay, instead of doing the Pandas info and the Pandas describe, we're going to meld both of them together and into this one thing of df polars.describe. Now, to be completely transparent, I don't know how I feel about this. I actually, in my personal opinion, I am okay either way. Like I'm okay with this. Because I'm not too upset that I'm missing out on the 25th, 50th, or the 75th percentile kind of things. However, it kind of does make me wonder what their rationale was thinking in keeping some of the Panda syntax the same and then deviating it for others. When we read on our CSV, that was basically the same that we did for Pandas. However, this is a little bit different, and I don't understand the rationale here. But I think this view is fine. I actually do kind of like it, but I would respect people out there that would not like that they chose to go this route. All right, so that is the describe function. Now, what else did I want to show here? I'm just looking at my notes. Okay, so another thing that I really like to do is I like to look at the value counts associated to a specific column. So let me just scroll back up here. So you can see the embarked feature. So just in case you're not aware what the embarked feature is, so there are letters representing where a passenger boarded the Titanic from. So there were actually 3 different ports where passengers boarded the Titanic, and I can't, to be honest, I can't remember what their names are. S stands for a city. I can't remember what the city is. So I like to look at these because these can be kind of informative sometimes. So in Pandas, I'll do df pandas. And then here in brackets, I'm going to call out the embarked column. And then we do value counts. And so then this is going to show you here. So this is showing that, 644 people came from the S place, 168 came from C, and 77 came from Q. Now, I guess let's just go, for your own benefit, I'm just going to look this up really quick. So, because this data set is housed on Kaggle. I don't know if it originally came from Kaggle. Oh, I guess I should say Kaggle. I actually learned this last week. It's not Kaggle, it's Kaggle. Well, I think so because I'm listening to the Kaggle book audiobook, and the narrator for that audiobook keeps saying Kaggle. So Kaggle, if you're listening and I am saying this wrong, just be aware that I am going off what your audiobook says. So anyway, so let's look at the data here, and then you can actually we can come down and see what each of these things are. Okay, so here we go. Embarked port of embarkation. So C stands for Cherbourg. I'm probably pronouncing that wrong. Q stands for Queenstown, and then S stands for Southampton. All right, so there you go. So coming back to here, and that's represented here. Now, the one thing that I've never really considered before with the value counts function is the fact that, and I even called this out above with the info function here, embarked has 2 nulls, This value counts function actually doesn't if you add these numbers up, it does not include the null function. So this is actually can be a bit of a misnomer because it's not telling you what is null. So let's see what polars actually does. And so this is polars fortunately does keep the exact same syntax. So df polars embarked dot value counts. So exact same syntax here, and you'll see the output here in a second. Output's a little bit different, and I actually kind of like this one better. Again, this is another tally up another win for polars on this one. I really like this little interface because now we're getting a little. Not only are we seeing the same information that we saw from above, but now we are also seeing the null values also represented here appropriately. So, golf clap for polars on this one. I really like that. All right, so that's all I wanted to show for the getting started. Now let's move into, I'm going to call this my data wrangling section. So different functions that we can do for data wrangling. Data wrangling. Okay. All right, I'm going to zoom in a little bit more so y'all can see better. And maybe I'll move my face out of the way, that might help you. Let's move my face out of the way. All right, let me take a sip of my Polar Pop. All right, I need to get sponsored by Circle K. Not really, but I do give them a lot of plugs. And I guess also a plug for a local business if y'all live here in Bloomington. I'm wearing my Windy City Wieners hoodie. Big fan of them. They have a daily special every day, different specials. So my favorite special is actually today, Saturday, 2 chili cheese dog specials. So highly recommended. Go check them out if you live here in Bloomington. Anyway, all right. So the one thing I mentioned when I did the df polars.head, or I wonder if tail works too. So if you're not familiar, tail just shows the last couple rows here. That it doesn't show the index values, but that doesn't mean we can't call things by the index values. So there are times when we want to get like a slice of data. And the way that we can do that is with the index value. So let's do it with the pandas first. So the way that we do that is df pandas, and then in the brackets we will do like I'm going to do 15 to 20. So this is going to grab rows 15 through 20 by the index value here. So let's go ahead and display that. So you can see here that we have a slice of data of our rows here represented appropriately. And then we can do, even though, again, we don't have the column name or the row name, the index value of the rows showing up above here, they're still there. It's just kind of hidden in the background. So df polars, let's do 15 through 20 again. And then you can see it's the exact same data. So this does actually work. So this is also nice. All right, so slicing works just fine. Now let's say we wanted to query the age of like all the teenagers aboard the Titanic here. So the way that we do that, there's a number of different ways that you can do it in pandas, and I would imagine there's probably a number of different ways that you can do it in polars as well. But I noticed that it is a little bit different between both. And actually, polars, I'm gonna give a little bit of a negative mark here because it's, in my opinion, it's not very intuitive. So let's look at the pandas. So the way that we do that in pandas here is df pandas age, and again we are looking for teenagers, so age, and then we're going to do dot between, and then so teenagers are 13 and 19, so between 13 and 19, and so now we have all of our teenagers between the ages of 13 and 19 here. All right, so the way that we do that in polars is a little bit different, and it's a little bit confusing in my opinion. So I'm going to do, the way that we do that in polars is df polars.filter. And now in order to, so here above, we reference the column by saying, okay, here's the name of my data frame. And then in between brackets, we call it the age function here. In order to, according to the documentation for polars, the way that you do this here is you actually have to do pl.col, so that polars.column, and then we pass in the age. And then instead of between, so we ran just between here above, this one's going to be is between 13 and 19. And we're going to get back the same information. It's just, and this is all the same thing that we're seeing from above here. So just to verify, Mrs. Nicholas Nasser, so Adele oh my gosh, I am gonna botch these names. But anyway, this first name here, or the Vestrum name here, you can see that it is represented appropriately. So we the good news is that we are still getting back the same information that we would from Pandas. It's just that the syntax is a little bit different. And now that I'm typing this, even though the documentation told me to do it this way, I kind of do wonder if it would work if like similar to above. So let's try this out. And if it doesn't work, then egg on my face. Oh wow, that actually did work. That's weird. I wonder why their documentation did that, because like I actually did not like that PLCL. Okay, so it actually does work this way. Maybe Polars just needs to update their documentation to be a little bit, because I guess the one thing that, and they're probably aware of this, the Polars people need to be aware of the fact that most of the people using Polars are going to be Pandas users, and so if they really want Polars to be a success, they should try to stay as like obviously I know that's not going to be perfect in every circumstance, but